When Ram officially introduced its Hurricane inline-six engine family, it marked one of the boldest powertrain shifts in modern pickup history. The move away from long-standing V8s toward a high-output, twin-turbocharged inline-six was not driven by performance alone. It was about emissions compliance, fuel efficiency, packaging advantages, and long-term compatibility with electrification. But as with any major powertrain launch, early adopters quickly asked the most important question: is it reliable? When the Hurricane engine first reached customer hands in the Ram 1500, feedback was mixed. The engine delivered exceptionally smooth power, strong low-end torque, and class-leading output in its high-output form. Yet technicians and owners also began noticing predictable first-generation issues. None were catastrophic design flaws, but they were significant enough to raise concerns. By the 2027 model year, Ram had quietly implemented a series of meaningful, reliability-focused revisions that dramatically reshaped the Hurricane engine's long-term outlook. This video explains what changed, why it changed, and what experts now say about the engine's durability after its early growing pains. Understanding the Hurricane's design philosophy. The Hurricane is a 3.0-liter twin-turbocharged inline-six developed by Stellantis from a clean-sheet design. Unlike legacy V6 and V8 architectures evolved over decades, this engine was engineered specifically for modern emissions, efficiency, and performance targets. The inline-six layout was chosen for its inherent balance and reduced vibration compared to V-type engines. This smoothness allows tighter mechanical tolerances, higher boost pressures, and more aggressive tuning without excessive noise or harshness. From launch, the engine was offered in standard output and high output versions, sharing an aluminum block, forged rotating assembly, and advanced cooling systems. On paper, the design was robust in real-world use. However, the complexity of twin high-pressure fuel systems and modern emissions hardware revealed the typical challenges of a first-generation high-performance turbo engine. Engineers later acknowledged that early calibration pushed the platform aggressively, leaving little margin for variations in fuel quality, maintenance habits, and extreme operating conditions. Early reliability concerns in the first model years, several patterns emerged. One involved turbocharger heat management. During sustained towing or repeated wide-open throttle operation, oil temperatures rose rapidly. While protective strategies prevented major damage, some owners experienced reduced power, limp mode events, and concerns about turbo oil coking. Oil consumption variability also surfaced. Some engines required more frequent top-offs than owners expected, especially those accustomed to naturally aspirated V8s out. Engineers later attributed this too early piston ring tension and cylinder wall finishing that favored efficiency over oil control. Cold start, roughness, and inconsistent throttle response were also reported, largely traced to early engine management software balancing emissions, compliance with drivability. Over-the-air updates improved many of these behaviors, but inconsistent update adoption skewed early reliability perceptions. Importantly, independent teardown inspections showed normal internal wear. Bearings, camshafts, and timing components exhibited healthy patterns, indicating that the core mechanical design was fundamentally sound. Why 2027 became the turning point? By 2027, millions of real-world miles had been accumulated across diverse climates and duty cycles. This allowed engineers to move from simulation-based validation to true long-term durability optimization. Rather than announcing a dramatic redesign, Ram introduced dozens of incremental refinements. One powertrain consultant described the strategy as death by 1,000 improvements. Individually subtle, collectively transformative. Key internal hardware updates: piston rings received revised coatings and slightly higher tension, improving oil control without increasing friction. Cylinder bores were finished with an updated plateau honing process, improving braking behavior and long-term sealing. Turbocharger oil feed and return circuits were refined to reduce oil dwell time in the bearing housings, lowering the risk of heat-related oil degradation. Timing chain, metallurgy, and guide materials were also updated to increase service life margins. Particularly for high-load and high-mileage operation, cooling system enhancements, thermal management received major attention. Early engines prioritized rapid warm-up for emissions, sometimes at the expense of sustained high-load cooling. For 2027, coolant flow strategies were radiator efficiency was slightly improved, and auxiliary cooling systems now activate earlier under prolonged stress. Coordination between engine and transmission cooling was also optimized, reducing cumulative thermal load across the drivetrain, especially important for towing in hot climates. Software, the quiet reliability upgrade, perhaps the most impactful changes came through calibration. Boost ramp rates were softened slightly, reducing transient thermal and mechanical stress while maintaining peak output. Fuel and ignition mapping were revised to better accommodate variable fuel quality, reducing knock correction events in long-term piston and bearing loading. Cold start strategies were refined to improve idle stability and reduce wear during one of the engine's most critical operating phases. Crucially, these updates are now factory installed, ensuring consistency across the fleet. Expert assessment. Independent engine builders and fleet maintenance specialists now report wear patterns in the 2027 Hurricane comparable to well-regarded turbocharged inline-six engines from other manufacturers. Bearing condition, cylinder wear, and valvetrain integrity all fall within expected norms at higher miles. Technicians emphasize that conservative oil change intervals remain important, particularly for towing, extended idling, and extreme heat. However, no systemic failure mode has emerged on the early generation refinement issues typical of advanced turbo platforms. The Hurricane engine was never fundamentally flawed, it was simply ambitious. Early concerns reflected the challenges of introducing a high-output twin-turbo inline-six into a segment long dominated by simpler, naturally aspirated V8Es. By 2027, a combination of internal hardware upgrades, improved cooling strategies, and mature software calibrations significantly strengthen its durability profile. Expert consensus now views the 2027 annual Hurricane as a solid long-term power. Provided owners follow proper turbo engine maintenance practices, it may not replicate the emotional appeal of a traditional V8, but from an engineering standpoint, it represents a confident and fully matured step into the future of modern truck power.